This is Beyond the Business, Weekly Digest.
Let's start with a simple question. When an entire global industry chooses a technology, is it because that technology is the best or because the least risky? Today I'm talking about LNG, liquefied natural gas, the fuel that over the last decade quietly became the backbone of shipping transition narrative. But LNG is not a revolution. It's something far more interesting. It's a compromise, and compromises in large systems often tell us more about the future than bold promises ever do. To understand LNG today, we need to go back about 15 years. In the late 2000 and early 2010, shipping was facing a growing pressure, not from technology and not from customers, from regulation. The tightening of sulfur limits, the push toward cleaner air in coastal regions, and eventually the IMO 2020 global sulfur cap created a moment where the industry needed an answer. Not a theoretical answer, a deployable one. LNG fit perfectly into that space. It was already produced at scale, it had an existing global supply chain, and most importantly, it allowed ship owners to reduce emissions without redesigning the entire operating model of ship. That was the key, because shipping does not change fast, it can't. Assets last 25 to 30 years, routes are fixed, margins are thin, so any fuel that enters this system must integrate into it, not replace it overnight. LNG did exactly that. By the mid 2010, LNG was no longer experimental. Engine manufacturers had major dual fuel technology. Ports started building bunkering infrastructure. Classification societies developed clear safety frameworks. And then came the acceleration. After 2020, orders for LNG powered vessels surged. Today, the scale is no longer theoretical. More than 1,000 vessels globally are already operating on LNG across different segments. Within container shipping alone, roughly 350 to 400 vessels either operate on LNG or are designed to, and another 500 to 600 LNG fuel ships are currently on order across the global fleet. This means that close to 10% of the world's commercial fleet is already either running on LNG or being built around it. For the container segment, LNG has effectively become the dominant alternative to conventional fuels. Most large vessels orders placed between 2021 and 2024 by major carriers were specified as dual fuel LNG. This is not a short term experiment. A vessel order today represents a capital commitment spanning 20 to 25 years, which means the industry is not just testing LNG. It is structurally integrating it into its operating horizon. This is not a niche trend, it's a structural shift, but not toward a final destination, toward a temporary equilibrium. So, why LNG? Because it solved three problems simultaneously. First, compliance. It dramatically reduces sulfur oxides and nitrogen oxides. Second, predictability. Fuel supply chains already existed. Third, and maybe most important, operational familiarity. From a ship operator's perspective, LNG does not fundamentally change how you run a vessel. And that matters because the real risk in shipping is not emissions, it's disruption. A fuel that reduces emission while keeping operations stable is far more attractive than a perfect fuel that disrupts the entire system. So here's the key insight. Shipping didn't adopt LNG because it believed LNG was the future. Shipping didn't adopt LNG because it believed LNG was the future. Shipping adopted LNG because it reduced uncertainty. And in capital intensive industries, reducing it is often more valuable than maximizing performance. Think about a ship owner placing an order today. So the question will be, what's the perfect fuel? What's the safest bet in an uncertain world? Right now, LNG still answers that question better than any alternative. But LNG is not a silver bullet, and the industry knows it. There are challenges: methane sleep, unburned methane released into the atmosphere, dependence on gas markets, which can be volatile, and limited CO2 reduction compared to net zero ambitions. So LNG is not the end of the journey, it's the bridge. And bridges are built not to stay on forever, but to get across. What's fascinating today is that LNG growth is happening at the same time as diversification. New vessels are being ordered not only with LNG capability but also with flexibility for future fuels. Methanol ready, ammonia ready, multi fuel capable. This tells us something important. The industry is not choosing one future, it's hedging several futures simultaneously. And that is a rational response to technological uncertainty. Another reason LNG persists is financial. Access to capital increasingly depends on ESG alignment. Banks, insurers, and investors look for measurable emissions reductions. LNG provides a credible pathway, not perfect, but quantifiable. And in finance, quantifiable progress is often enough to unlock funding. So LNG isn't just an environmental decision, it's a financial strategy. If we step back, LNG is not just a fuel story. It's a story about how large systems change. They don't leap, they transition through stable phases. LNG is one of those phases. Technology that allows movement without instability. And in complex global infrastructure, stability is not the opposite of change. It's the condition that makes change possible. So, what happens next? LNG will likely remain a major part of the fuel mix for the next decade or even more, not because it solves everything, but because it buys time. Time for new fuels to scale, time for infrastructure to develop, time for economics to align. And time in energy transitions is the most valuable resource of all. So when we look at LNG, we shouldn't ask whether it's the perfect solution. We should ask what it tells us about how industry navigate uncertainty. Because the real story here is not about gas, it's about decision making in a world where the future is not yet clear. And LNG for now is the fuel that keeps the system moving while the next chapter is still being written. Let's move on to the second part. This week, the energy conversation is once again dominated by one word: electrification. Across policy announcements, infrastructure funding, and industrial strategies, electricity is being positioned as the most immediate pathway to reduce emissions across large parts of the global economy. Not because it solves everything, but because it is the fastest lever available right now. And that distinction matters. Because when an entire system starts moving in one direction, it is rarely because the destination is clear. It is because the alternative is uncertainty. So today we are not asking whether electrification is good or bad. We are asking a more interesting question. What exactly is happening right now? Where the capital is flowing and what this tells us about how the transition is actually unfolding. If we step back and look at the last 12 months, a pattern emerges across regions. In Europe, the largest share of transition funding is no longer going to fuels. It is going to infrastructure. Grid expansion projects, cross border interconnections, port electrification, shore power deployments, and industrial electrification clusters. The logic is clear. If demand shifts to electricity, the system must be able to carry it. In the United States, the narrative is framed through industrial policy, for example. Large incentives packages are accelerating electrification in manufacturing, transport, and power generation. And this is not only environmental, it is strategic. Energy independence, supply chain resilience, and domestic industry. Meanwhile, in Asia, particularly in China, electrification is not a plan, it is an execution. High voltage transmissions networks continue to expand. Electric transport scales rapidly, and industrial processes are increasingly shifting toward electric systems. Across all three regions, the message is consistent. Electrification is no longer experimental. It is being treated as the backbone of near term transition policy. When we follow the money, the picture becomes even clearer. The largest investments are concentrated in four areas: power grids and transmission capacity, renewable generation tied directly to electrified demand, electric mobility ecosystems, and industrial electrification. What is surprising is what is not at the center. Hydrogen is still largely pilot scale, ammonia remains developmental, synthetic fuels are niche. Electricity, on the other hand, is already integrated into every system. That makes it unique and scalable, not because it is simple, but because the infrastructure foundation already exists. Electrification delivers something that energy transitions rarely achieve: immediate, measurable impact. When combustion is replaced with electricity, emissions at the point of use drop instantly. That is politically powerful, financially attractive, operationally visible. For policymakers, it provides progress within election cycles. For investors, it offers quantifiable metrics. For industry, it reduces compliance risk. Electrification aligns timelines. And in large systems, alignment is often more important than perfection. But the speed of electrification also reveals its boundaries. Electrification works best in environments where demand is predictable and infrastructure is fixed. In the cities, in the rail, buildings, ports, short distance logistics. In these spaces, electricity replaces fuel with relatively manageable adjustments. But once we move into heavy industry, long distance transport, and global shipping, the equations becomes more complex. Energy density requirements increase. Operational flexibility becomes critical. Infrastructure must operate across borders. Here, electrification stops being a replacement strategy and becomes a complementary one. This is where the narrative becomes more interesting. Electrification is often presented as a clean solution. But what it really does, it shifts where the system carries its burden. Local emissions fall, but upstream pressures rises. More demand on grids, more reliance on raw materials, more manufacturing capacity, and more transmission infrastructure. The energy system does not become lighter, it becomes reconfigured. And that distinction is really communicated clearly. Because electrification is not a simplification, it is redistribution of complexity. And if we step back, electrification is not the end state of the transition, it is a stabilization phase, a way to reduce emissions quickly while buying time for deeper structural changes that are still technologically or economically uncertain. That is why electrification and LNG are expanding in parallel. They serve similar role in different domains. One stabilizes infrastructure pathways and the other stabilizes operational continuity. Together they reduce volatility. And reducing volatility is the hidden priority of the transition. The blind spot in the electrification narrative is not technical feasibility, it is a system readiness. Grids take decades to expand. Infrastructure upgrades require enormous capital. Permitting timelines are long. Material supply chains are fragile. So while electrification scales faster than new fuels, it still moves slower than policy ambition. And this creates a structural tension. Targets accelerate, system adapt gradually. That gap is where risk accumulates. For shipping, electrification is not a fuel solution, it is an efficiency solution. Shore power reduces emissions in port, electrified terminals reduce operational footprint, digital and electric systems improve energy use. But for propulsion at global scale, electricity does not replace fuels. It optimizes the systems around them. And this reinforces a broader reality. The ship in transition will not be driven by one technology. It will be shaped by layered adjustments across the entire network. So, what does electrification tell us about the transition as a whole? It tells us that the system is prioritizing what can scale now over what might work later. It tells us that stability remains more valuable than perfection. And it tells us that transition is not a straight line toward a single solution, but a sequence of phases, each one designed to reduce uncertainty before the next becomes viable. Electrification is not the destination, it is the phase that allows the system to keep moving while the deeper questions remain unresolved.